Let's now explore algorithms that have quadratic runtimes. There are many algorithms that could have quadratic runtimes. Some sorting algorithms have it, for example, bubble sort, insertion sort. Other algorithms, for example, finding a duplicate on an array, could be implemented using a quadratic runtime. So let's do an example so you get a feeling what it looks like. So we are going to cover now quadratic runtimes. And as I mentioned, we're going to do find duplicates. So there we have it. We have an algorithm that return true or false if an array has a duplicate. So let's see how it runs. Let's do an example. Let's say n is equal to 3, and then we have the array. Say we have the array 1, 2, 3. So this would be has duplicates, right? Has duplicates. So let's see how many instructions does it run. So in this case, let's say this will be do an assignment, then this part will run n times, which is the array length, right? So let's do a marking here. This part here, this whole block, will run n times, right? And then we have something similar here. So we have that this block inside this other for loop is going to run n times as well, because it's going to run from 0 to the end of the array. So it's going to go through each one of the elements. And then this piece in here will execute depending on the values. So let's say we have 3 for this case. So this will be initialized and then it will run. So let's say initialization is 1, and then this whole block in here is going to be executed 3 times, but this one inside it is going to be multiplied, because it's going to do 0 on A 0 and B 0, right? And then B is going to advance to position 1, then position 2, and then A is going to move to 1, and then it's going to compare. So it's going to go through each element twice in a nested fashion. So what we have here is this inside here is going to be n by n. So if it's 3, we're going to have this little piece in here executed 9 times. All right. What happened inside here? So this whole block will be 9 times. What happened if we have, and then it's going to return, right? What is going to happen if n is equal to 5? So the same, A is going to be from 0 to 4, and then this one is going to also go from 0 to 4, but inside this one. So this part in here, how many times it's gonna be executed? 25 times. You can even run this program and add a printout in here, so you can see it will print out like 25 times. And this will be 1, and this will be 1. What about if we have an array that has 10? So at this point we are going to see that this is n by n, so it's going to be 100 times. So as you can see, this, what is 2 out of 100? So as you can see, this is the main part, and as we figured it out, is n squared. So whatever you have, the main, this part is going to do the most computations, and it's going to be n squared. So if we do a graph, it's gonna look something like this. So here is the time complexity of the runtime, and here is the input size. And then when we have 3, an input size of 3, we get, so this is 3, so this is 9, so this is 12, and so on. So when we have 3, we have 3. When we had 5, we turn out to be 25, all right? So something beyond here. And then when it was 10, it was going to be like 100. So it's going to go off the chart, but we know this is a quadratic function, so it's going to be like a parable, something like this. So as you can see, the curve is much more steep than the linear function, which was growing at a linear rate, and this one is growing a quadratic rate. So this can be represented by the big O notation of n squared. So that's the growth of the function for the quadratic time. So as I mentioned, many sorting algorithms has this runtime. Yeah, and every time that you have to go through an array, you have nested loops. That's likely to be quadratic, even though you could skip some of these. For example, you could go, instead of starting from 0, you can go to a plus 1, start here. But you know that big O notation is about the worst runtime. So in the worst case, it's roughly like n squared anyways. All right, so that's quadratic runtime.